Now that is describing the null hypothesis. You can remember that the null hypothesis is what is assumed to be true by society, or what is accepted as true. Now, maybe that is you assume that the average score on a test is 75% going in, and then you want to test to see if it might be different. And so your null would be the 75%. And the wiki gives an example of the body temperature. Now it's accepted and taught generally that the average body temperature is 98.6. And so if you wanted to test to see if that was different, you would choose 98.6 degrees as your null hypothesis. Question number 2. Does HA, which means alternative hypothesis, that's how we represent that, below represent a one-sided or a two-sided alternative hypothesis? Okay, so the quick answer is this is a one-sided alternative hypothesis, and I'll show you why. So our null hypothesis, we write as mu equals 0, is how they have it. And for their alternative hypothesis, we have a couple of options. Okay? The first one is that mu simply does not equal 0. Another option might be mu is greater than 0, and possibly even mu is less than 0. Okay? So here, maybe we're talking about the temperature in Idaho, in Rexburg during January. And somebody assumes that it's 0, that the temperature is 0 degrees in Rexburg. But they want to test to see if it might be different. So if you want to test to just see if simply it is different, then you choose this hypothesis, this alternative hypothesis, the not equals, which represents we don't care if it's bigger or if it's hotter or cooler, we just want to know if it's different. But if you think it is actually hotter than 0 degrees, then you would choose an alternative hypothesis of greater than 0, in which case your statistics at the end will tell you if the temperature is above 0. And then if you think that it might be less than 0, even colder than 0, then you could choose this one-sided alternative hypothesis. And so the not equals is two-sided, and then both the less than and greater than are one-sided. And that is how you can tell between a one-sided and a two-sided alternative hypothesis. Fill in the matrix below with the correct response. Okay, so this is we have a little diagram here describing the possible outcomes of our survey. And so this is talking about the null hypothesis. So when it says true, that means in reality the null hypothesis is actually true. Okay, this says that in reality the null is actually false. And then here we're saying this row represents failing to reject the null hypothesis, and this row represents rejecting the null hypothesis. So if the null hypothesis is true, and maybe we can go back to the body temperature, if the null hypothesis, which was 98.6 degrees, is true, and we fail to reject that null hypothesis, then we've made a good decision, or a correct decision. We have failed to reject that it's different. Basically, this is showing that it is the same. Now, if it is false, but we fail to reject it, so let's say in reality the average body temperature is 100 degrees, but our sample came back and said that nope, it is 98.6, but in reality it's not, then we have made a type 2 error. Okay? Now, if on the other hand, if the null hypothesis is true, but we reject it, that is a type 1 error. Okay, so this is if the body temperature really is 98.6, but somehow in our sample, maybe we went to the hospital or something. We got temperatures that were all really, really high. And we found, no, the average body temperature is actually 102 degrees. Well, that is called making a type 1 error. I like to remember it by saying a little phrase that a type 1 error is rejecting the truth. Okay, so type 1 error means you reject even though it's true in reality. Now, oftentimes you don't know what this true or what reality really is, but there's always that possibility that you might reject the truth. And then finally, if you reject what is false, then obviously you've made another good decision. Okay, so that is our diagram of type 1 and type 2 errors. Okay, first off and most simply, the level of significance is represented by the Greek symbol alpha, the lowercase alpha, which looks like this, kind of a small Jesus fish. Okay, now the level of significance is a number to determine the p-value if the p-value is small enough to reject the null hypothesis. Now, what that means is this is something that we choose before we do our survey. And normally, it's there are a couple that are most common, 0.01, 0.05, and 0.10 are the most common ones. And then what we'll do with these is at the end, we will use these numbers, or whichever one we've chosen before the survey began, and we will compare it to our p-value. And that will be able to tell us whether we are going to reject or fail to reject our null hypothesis. It is also this level that you choose beforehand is also the probability of committing that type 1 error that is talked about in the second part of question 2. And so if we chose 0.05, then we have a 5% chance of rejecting the truth, or a 5% chance of committing a type 1 error. Question 4, write down the formula for computing the test statistic for the hypothesis test for a single mean when sigma is known. Okay, that key word right there at the end, sigma is known, tells us that we are going to be working with a z-score. And so the formula for the z-score is x bar minus mu divided by sigma divided by the square root of n. Okay, so let's take just a second and break down what each of those pieces represent. Okay, so the x bar is representative of the sample mean. Okay, the mu represents the population mean. This little sigma represents the standard deviation. It's the sigma. And the n is represented by is representative of the sample size. Okay, so a quick review. Z-score is equal to the sample mean, x bar, minus the population mean, mu, divided by the standard deviation, sigma, divided again by the square root of n, the sample size. Okay, so let's break down this worked solutions paragraph. P-value is the probability of obtaining a test statistic at least as extreme as the one that was actually observed, assuming the null hypothesis is true. Okay, so let's take this back to the body temperature example that we've been working with. If our null hypothesis is 98.6, and let's pretend that at the end of our survey, at the end of our sample, we found that actually the temperature that we got was 95.0. Okay, so that's significantly lower. Now, the p-value is the percentage or the probability that we just happen to pick the 100 people and all of 15,000 BYU Idaho students that have an extremely low body temperature. And so if you remember, body temperatures being normally distributed, and we chose our sample, and we got 100 students out of this whole area right here represents all of the students of BYU Idaho, and this is the average of, or the median, the 98.6 degrees. Now, if we're going to collect 100 students, and remember this represents 15,000, it is possible that we could choose all 100 from just this section right here. And so it's possible that so this is our mu, and it's possible that our x bar could be 95, or the mean of our sample. Now, what is the probability of that actually happening? That's what your p-value is. And so it's the probability of obtaining a test statistic like 95 degrees, at least as extreme as the one that was actually observed, assuming the null is true. So that's if we accept this to be true, what's the probability that we'll just happen to get people from just this side by random sampling? This is used in a hypothesis test to see if the probability of obtaining a test statistic, at least extreme as the one observed, is statistically significant. Okay, so then after we get our p-value, that's when we will compare it to our level of significance, which was the alpha, which was answered in the previous question. If the p-value is lower than the level of significance, then we reject the null. Okay, and then the other way around as well. If it's greater than, then we fail to reject. So at the end of our study, if we get at the beginning of the study, remember, so before the study, we choose our alpha. Let's say we choose alpha to be 0.05. Okay, then after, we're going to get a p-value. And let's say for this test, we found our p-value to be 0.03. Okay? Now, to decide whether to reject or fail to reject, we have to compare these two. And the catchphrase that I like to use that helps me remember whether to fail to reject or reject is if the p, let's see, if p is low, reject the null. Okay? So if the p-value is lower than alpha, then we reject the null. So now it becomes pretty easy. If our p-value is 0.03, alpha is 0.05, then we reject the null. If the p-value was 0.09, then the p-value is not lower than alpha, so we fail to reject the null. And that's a p-value. If the null hypothesis is rejected in a hypothesis test, what is concluded about the alternative hypothesis? Now, that's pretty simple. If in the null and between the null and the alternative, you have all of the possibilities. And so if you reject the null, then that means that you found enough evidence to suggest that the alternative hypothesis is true.